Now, let's start with the external device monitoring. The external device monitoring, according to the ISO 30849-1, the safety-related parts of the control system, or category 2, shall be designed to that their function should be checked and suitable in intervals by the machine and the control system. The check of the safety functions shall be performed at machine start up, so when we start the machine, and prior the initiation of the hazardous situation. That means, as example, starting a new cycle or starting a new movements, and this initiation must be, and these checks must be automatic. So we are always looking for the reaction. It's our target. The external device monitoring is considered an output function. So that means this function is linked with the primary safety function. This primary safety function can be a protective stop, emergency stop, a zone, or individually. So this signal is a feedback that comes back to the primary safety function and is looking for the switching device and the status. And depending where the signal is connected, we will have a different results. Let's have a look in one complete example. Here we have a kinematical chain and also the electrical part. Starting from the dangerous movement where the people can be injured, continuing with the gearbox who is transforming the energy, rotating energy from the input from the motor to the different relationship. If we are monitoring this part, we can have also some different value because the gearbox can be disattached of the dangerous movement and different values. And also from the other part, we can continue with the motor. Motor is converting electrical signal to a movement. And last part, but not the least, we have the contactors who are switching on and off the energy, electrical energy, and the safety module who is monitoring the entire system. Let's identify different external device monitoring systems. Here, following our previous example, we have the signal, or the source of the signal is attached directly to the dangerous movement. So here you can see the cogwheel or the encoder are directly attached. With this directly signal monitoring, we have a very reliable and trustable directly link connection. So this EDM function managing the logic is providing a very trustable signal. In this other example, we have an indirect signal monitoring. So we are monitoring the dangerous movement who is linked with the gearbox, who is linked with the motor, and this motor is linked with the electrical source, and we are having the information from the mirror contacts of the contactors, so very indirect signal. So this signal comes from devices who are mirroring indirectly, so that the signal is not very reliable. So the amount of devices between the dangerous movement and the signal source could be for many reasons unlinked. So this signal is changing, but it's not really healthy. Of course we can use it, but we need to add a lot of extra maintenance and a lot of tests in our regular testing for the machine. In this second example of indirect monitoring signals, so we have the monitor, the cogwheel, and the encoder are directly attached to the motor. So that means we have one step less than the previous example, but the points that can fail or the probability of failure of the motor linked with the gearbox and the gearbox with the dangerous movement, it's a little bit shorter or smaller than the previous one, but it's still a very unhealthy signal. So this unhealthy signal must be covered or adopted with a regular checks done manually by safety experts. In this case, the external device monitoring is a permanent signal. Let me explain. Here we have a motor who is moving or and attach and converting from electrical part or power or energy to a mechanical and motion. So we have in this red box, we have 2 voltmeters monitoring all the lines. So here we can measure the volts that they are using. Also in the same box, we have toroidal signals, and these signals are monitoring and linked with amperimeters. So that means we are monitoring the signals permanently. So we know if the motor is moving or the motor has inertia. And with these systems, we can permanently monitor these signals. And of course, these signals can be transferred to the safety relay or to the safety PLC, and this safety relay or PLC needs to understand this kind of signals. This methodology is very reliable and trustable and very healthy signal. In this example, also we are looking for external device monitoring indirect, but in this case, we are looking for a sequence. So once we are switching off these contactors, we are waiting for a while until we have the feedback of the signals. So this is a sequence. First switch off, after that switching on. Sequential indirect monitoring. Let's continue with the summary of the EDM. So here we are showing the 4 different types. Some of these types need additional measures to be taken, but all of them are correct and legal. So direct signal monitoring, where the signal or the danger is created, we don't need additional measures. We can have a directly information of the situation. That's exactly the same with the permanently signal. As we are measuring and having a direct signal, so we are measuring and we don't need additional measures. Nevertheless, when we are doing indirect signal, like a mirror contacts, and we have an unlinked mechanical information, we need to add additional measures. So that means the initial check when the machine is started and regular check must be detailed in the operating instructions and in the maintenance book. Likewise with the sequential signal monitoring, because at the end we are doing a kind of sequence, starting from one point and to the other. So that means we really need to maintain this function together, the technical part, and together with the regular inspections. So that means you need to have in your factory, if we are supposed to be end users, we need to have in our factory skilled people to do this maintenance test and this safety test. Let's look for a very typical example on EDMs according to performance level E. Now you are seeing the 2 motors with contactors who are the power part, and these contactors should have a mirror contacts. These mirror contacts will be implemented in the safety circuit. In this case, we are linking them to a safety emergency stop module. That means the EDM function will be only monitored and linked with the safety emergency stop part. So in this case, only when the emergency stop push button will be pressed, this part will be monitored. So that means the number of operation or the number of checks is limited or linked directly to the emergency stop module. That's a typical example of performance level E. Or also we can monitor or we can link the EDM with the safety module of the guard of the right, or also the safety module on the left. So that if we change this EDM linked to the safety module, we can increase the number of operations according to each opening and closing of the guard. That is something that you must be aware and you need to think about it.